This conference will now be recorded.
Okay, cool. So I think we're going to start out with my Helix article. This is an article I wrote back a few months ago, or a month ago, yeah, or about. So essentially, this is the basis of CNNs, and this is how I think we should start. So I'm just going to go through this article. Something we spent a lot of time on, and it's definitely useful. So what are neural networks and why are they called neural networks, essentially? So in your brain, if you've taken basic chemistry or basic biology, my bad. So you know that like in your brain, right, like there's these synapses that interact with neurons, right? So the entire point of and that causes response and stimulus, which is the definition of human intelligence, right? So essentially what scientists, researchers, experts, what they wanted to do is they're like, oh, this is a cool concept, and we want to integrate this into technology because a lot of technology is super instruction and algorithmic based, right? So they were like, okay, so let's integrate these ideas of human intelligence that the core basis of human intelligence, which is neural networks, into humans under this idea of AI, which is a big word, and I have a whole article just talking about the difference between AI and deep learning, and this is deep learning, but yeah. So these neural networks, the ones I like and personal favorites, I love convolutional neural networks, so we're going to talk about them, and they're also super useful. They're getting huge right now, so it's really cool. They have a lot of applications, but the main one is image detection. So just for a second, think about how many problems we have in this world that could just be solved by image detection, and that's essentially the goal of CNNs. So essentially we'll walk through a data set which is super popular. It's called the MNIST data, and we'll program a convolutional neural network to deal with it. It analyzes digits from handwriting, which can also be super useful because of crime and stuff like that. So so a bunch of our team at Helix work in neural networks, particularly me and Andrew, with Andrew working in medical imaging, and I'm more strict energy-based models and work around that. But other than that, so I'm going to talk about the structure of neural networks. So the first structure, so you're passing your image, right? And in the image, each image on a computer is made up of pixels, right? So these pixels have different intensities, and that's a numerical value that you can assign to each pixel. So essentially the convolutional layer of the neural network creates a feature map that holds features detected from the filter that scans the image a few pixels at the time. So essentially what this means is that if the convolution looks at each section of the image, and then it finds the most important features, it finds the most important it uses a filter to filter it out and normalize the data, because you have a lot of it and you just need to normalize it, for instance making it grayscale. So then what happens is a classic example of deep pooling layer is it looks at the maximum of each section that was analyzed, and it finds the highest the highest numerical value, but that's numerically. But if you put it down in purely conceptual perspective, essentially what the pooling layer is it allows the it finds the most important features, because there's so many features in one image, right? So you definitely need to condense it down. So yeah, if there's any questions, can someone unmute and ask me, because I'm not looking at the chat. Okay, so the next layer is so then there's like these 3 layers of that are like essentially the same. So the first of the 3 fully connected layers are the flattened layer. So essentially, the flattened layer normalizes the data and allows it to go into one like single vector so that it can get inputted into the dense layer. This analyzes it. It's called a hidden layer, and then it works more like with it. So, and then eventually it outputs a classification, which is, that's AI, right? So like if I were to give you an image of a banana, then hopefully it takes out an image of it says banana at the end. So
Wait, Josh, I had a question. You know how you're saying about like detecting parts of an image, like finding what is it, like consistencies between something. So like for example, if you're trying to do facial recognition, you'd like try to find an eye or a mouth. But then like if you want to find an eye, you'd have to find characteristics of an eye. And then wouldn't you just like go down like a loop and like a spiral downwards to try to find like the most unabstracted view of what you're trying to look for?
yeah, so yeah, that's a good question. So it's this so like the mod like okay, going back to like the basics of machine learning, right? Your inputted training data, which we'll see as we're like, programming and stuff, but your inputted training data, and then you compare that to validation data. So the training data allows you a perspective that like trains the model to like our brains, right? So let's say I saw a red shoe, a blue shoe, and a green shoe, right? And someone told me that it was that the red shoe was red, the blue shoe is blue, and the green shoe is green, right? So when I look at a different shade of green, right, then like what's to say I can detect it? So we feed these images like to a computer to like the model, and then the model trains on these images and then uses it as like a general trend and then tries to analyze stuff, if that makes sense.
Yeah, okay, thank you.
Okay, I do.
Yeah, that answered my question. Thanks.
Oh yeah, no, I was just looking at the comment. Okay, so I don't understand how you can determine the most important section. So Sarah, like that's actually a really good question, so don't be nervous to ask that. But essentially the way you can do that is like each thing has like pixel values, right? So like so when you look at an image, it's just a bunch of pixels that have certain numerical values assigned to them. So finding a maximum number of a filter is like, yeah, it's hard, like theoretically, like it doesn't show much theoretically, but like when you put all those maximum numbers together, you get the important features that get emphasized in the network, like in the output. So we'll see more of them, but like as we walk through and like run stuff. So a lot of this will clear up as we start going in. So is everyone on Kaggle? I just need like a quick yes, I'm on Kaggle. Okay, so everyone get on Kaggle and create a new notebook. Here, I'll send you guys the link to the notebooks. Kaggle's also really cool, like just generally. So okay. Okay, cool. Is everyone on the Kaggle? Like the notebook section. I just sent the link, Jalen. So go to the notebooks and then create a new one. So tell me when you guys are there. Your screen should look something like mine. And then just call it like CNN tutorial, hack the Helix. Yeah, I just need a quick done from everyone and then we're good. So your guys' screen looks like this, right? Okay, cool. Okay. So the majority of you guys are good. So let's move on. Okay, so starting off with the imports. So go to the top box where it says like that, like import stuff. Yeah. So type in import Seaborn as SNC. No, that's so false. Light does not look better, but okay. Import matplotlib dot pyplot as PLT. I will explain. You guys will just like see that what these like mean. And then this is just a fun one. Import warnings, and then warnings dot dot filter warnings ignore. Okay. And then next thing you want to do, import OS, and then tell me if you guys have any questions or want me to slow down or anything. I don't like doing that. So print OS dot lister dot dot quote dot 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 slash input. Okay. Everyone good? Tell me in the chat if everyone's caught up. Or like, yes, good, cool. Okay, so now you want to go to the corner where it says add data and then click on it. And then search in the search databases, search MINIST. And then the one you want to click, oh, actually, it's digit recognizer. Search that up. Okay, so yeah, digit recognizer, boom. You want to click on that, and then should take you to a link. Okay, never mind. This is the wrong one. So hold on, let me find the right one. So digit recognizer. Okay, so okay, sorry. So everyone, okay, my bad. So copy what you have in the box and then just close it out and go to, I'm about to send you guys a link. So go to, hold on, yeah, it's fine. Okay, so go to, I have to retype it, but it's fine. So here, go to this link. Oh wait, go to this link. Yeah, go to that link and then click new notebook in the corner. And then it'll give you like a competition ID and stuff, but don't worry about that. Create. So create a new notebook and you'll have your data. Tell me when you guys are all done, like in the chat. I will take a look. Do you guys need help or anything? Tell me when you guys are all there. Good? You have to click new notebook. So you should get a screen like this. If you have it pasted, I had to paste the link, so I could not copy it, but yeah, I'll type it out really quick. And memorize it. So okay, so everyone has this, I'm pretty sure. Okay, and then /. Okay, so now if you check your data, you should have this thing called the digit recognizer folder. Don't play with it, but like you can just look at it. Like it's there. So that's the data you'll be using to run your model and stuff. Okay, cool. It's not Helix. Okay, cool. So run this cell. So you click the little blue run button and should get you that. Huh. Oh, sorry, my bad. So it's /input/digit dash recognizer. Try that. It's running the wrong thing. Yeah, there we go. My bad. So yeah, you got your digit recognizer there. So that's all cool. Are there any questions? Like need me to slow down or anything? Okay, yeah. Do warnings. Cool. Okay. Everyone good? So I'm just gonna move on. So train, yeah. PD.read. I'll explain this. Give me 1 second to just type it out. /input. Okay, so the first line that we just wrote, it essentially uses Panda, which is this. It's a Python data processing library that, so it already says it because that's probably one of the most popular commands, but it's a data processing library. So now if you do train.shape like that, and then train.head, you will see a few things pop up. Just run that for fun. And then you should see, oh, sorry. So you have to do /digit recognize recognizer /TrainCV. You have to do that. And then train head, and then so train.shape essentially prints this out. So you should get a neat little table that has a lot of data in it. So yeah, it all looks black, but there's more stuff to it because you can see it skips like a lot. But yeah, the next thing you want to do is, so that's your training data. That's like what you're gonna use to like give your model information. Then you read test data, and then that is test equals PD dot read. You can even copy the first one if you want, but yeah, so, and then you want to go print test dot shape, and then test dot head. Okay, so this will now do the same thing, but on a different data set, and I keep forgetting to do digit dash recognizer because this is weird. I've never had to like do it like that. So yeah, so you should get this number here. For this one is 42,000 by 785. This one is 28,000 by 784. So the head, so the train.head or the test.head is essentially the like top levels of the data set. And then this is like how it's shaped. So train.shape is like how the data is shaped. So like this is the amount of images. As you can see, this is like a lot of images. So yeah, this is a big data set. So the next thing you want to do is yeah, so the next thing you want to do, add a new box, file not found. Okay, Jalen, so yeah, I got that error too. You have to do this, or it should look like that. Or if it's for the first one, then it should be train.cv. CSV, sorry. Okay, check your, is everyone else good? Just saying, like, is everyone else okay? Like, tell me if your guys' are working or not. So Jalen, does your thing look like this? Does your like input look, does it say like input and then does it have a folder? Huh? Not working. That's weird. Jalen and Shreya, do you guys, or Jalen and Sarah, do you guys have a folder? So it says input, right? Does it say digit recognizer? Oh yeah, no. So it has to be exactly like that. Sarah, what's your problem? What does it say? Like, does it say file not found? Okay. I'm going to continue. Is it good? Mine says PD not defined. Okay. Go up here, and then you should have this import, and then you have to run this though. Like run this entire thing. Like you have to run the cell. You can't skip over it because that's the import. So Sarah, does yours work? I don't know. The line is wrong. Well, it says the line is wrong. Okay, yeah. Yeah, I don't think you have. Did it, Sarah? Did it say this at the beginning where it says test.cv? Like, did you get this printed out? Oh wait. Okay. Sarah, I don't think you put a slash in front of input. You didn't put a slash in front of input. Yeah. That's what I thought too. Okay. Cool. I'm gonna keep going. So sorry, let me think. Okay, so so now we have to put labels into the y train variable. So the way you do this is y, capital Y underscore train equals train quote label. So and then you want to drop the label column in this one. So because when you want to look at the data, right, you don't want it having, you know, this random label column right here, like right here. So you want to drop that. So you say x underscore train equals train dot drop labels equals quote label dot axis equals 1. So yeah, so essentially you just drop the you drop the label essentially. Oh wait, I screwed it up. So yeah. So essentially this just dropped it on the first axis, if that makes sense. So now the label won't show up. Run this, it won't do anything, but it actually does in reality. So go here, and then now you want to plot the data, right? So you want a way to so you always want a way to visualize the data. So just like more on the data set, like this is a class of, this is like recognizing digits 0 through 9. So all of this is like kind of auxiliary, but it's just better to like start visualizing data when you're first starting off and learning machine learning. So tell me if I'm going too fast, by the way. For train, and then comma palette equals quote icefire. That's like just to make it pretty, the palette.icefire thing. So then plot.title. So you want a title on your graph, number of digit classes, and then y underscore train dot value underscore counts. So essentially, like that's just counting your training data. So I'll just run it and then we'll see. So yeah, as you can see here, this is just like going through the digits and 1 through 0 through 9 and just counting the images that the training data provided. And then this is just oh my god, okay, I'm gonna turn this to light map, hold on, because you guys probably need to see this easier, but yeah. So okay, cool. So yeah, you have your number of digit classes and then the count of each image that like is getting trained and stuff. So then you want to create a new code box. So now you want to just randomly plot some samples. See, it's always good to look at your data because then you get a better sense of what you're working with. So image equals x underscore train dot iloc 0 dot as underscore matrix. So I'm not gonna like really go in depth of like conceptually behind these like you know, drawing out your images stuff, because it's just like you know, testing it out. In fact, I think I'm gonna copy and paste this to just show you. So there's no need to copy this part down. I'll just copy and paste and show you. I'll tell you when to copy stuff down. So hold on, let me change my window. Okay, apparently this like whenever I change my window, like it goes, my screen share turns off. So tell me if that happens. Tell me if my screen turns, like unmute and tell me because I can't see chat.
Yeah, it's off.
Okay, that's fine. It should come back on in a second. Give me 1 second. Give me a second because it's like turning on. Okay, it is almost on. It says loading, so getting. So, okay, yeah, here it is. Let me reshare my screen. So, here. Okay, so we're gonna load the data set. So, gonna run this. Oh, I forgot to run my first thing. Yeah. So, all our loading stuff, you guys already have this. I just need to rerun it. It's running now. Okay, so if you want to copy this down, you can. It's not necessary though, because right now we're just looking at the data and how it interacts. So this is just a random image. So this is like, you know, a random image of like a number. So like this in case would be 1 because of the pixels and like just how it interacts with pixels. And then you can plot that image on something. So this would be a 4. Yeah. So okay, let's go over this. So the next thing is normalization of the data. So now that we've written everything down like that, I'm gonna go back to my screen. So, okay, so normalizing the data, what does that mean? So essentially what we're gonna do is like, color is obviously like not important in this scenario. Hold on, I'll be right back. Okay, sorry, my bad. So yeah, so so normalization, right? So this stuff is not that necessary. I'm just gonna delete this because I had to collapse this. Okay, so yeah, this I'm just gonna delete. So you guys just saw like me running the other one, which had the completed, you know, normalization, like plotting it and seeing how the data works. So what is normalization? So normalization, or normalizing our code, or normalizing the data, is going to be like, so every feature has this like color, right? Like obviously. So you want to make a uniform color. So that's why you normalize your data. So in this case, we're going to perform a grayscale normalization. And in that, like, the reason we do this is because like the CNN just runs faster generally if you do that. So this is how you perform it. Please copy this part down. So if you want to visualize it too, then you can just say and then you can just look at it and visualize it. So And this is just like Python semantics. So if you run it, then it looks like that. So this is like just the amount of images and then the normalization. So that's cool and all. And then you want to reshape the data to, so reshaping the data, in this case, you'd want to make it to train and test data, because you want some data to be used to train your model and like input data, and you want some to validate it and make sure it like actually works. So you essentially reshape the data, something like this. Tell me if I'm going too fast. I like unmute because then again I can't see chat. 28,1. So now you just made all image. You made all the you made all the tests, the train images, 28 by 28 pixels, and you want to do that for the test too. And then, so then you want to print out the data to see it. So train shape. And then so is everyone caught up? Any questions? Anything you don't understand? Okay. Okay, so everyone's caught up? Okay, yeah. You guys take your time. That stuff. Okay, tell me, so go up. Okay. I'm gonna go to the reshape. So image equals image dot reshape. Jalen, don't worry, you don't need to copy that. That should not make. Wait. Okay. Yeah. So what? Oh, reshaping the data. This one, right? Yeah. Okay. What should I do if it says that Y train and X train are not defined? I'm assuming that's you defined it as. So X train. So you should have defined it up here. The first time we defined it. So if you look at the code, the first time we defined it was here, like these two. So you have to run that code. Also, yeah, it should be capital X, capital Y. Like that's how I originally defined it. Rishi, are you good? Or no, not Rishi. Shreya. What's not running? Okay. Gonna keep going. So yeah, so then you want to, so does everyone understand like why we want to reshape the data? We essentially want to make it into like a channel in which Keras can use the data. So Keras is, by the way, this convolutional neural network thing that we will get more into. So then you want to do some label encoding, which is essentially allow the data to go into one vector so that it makes it easier for the data to analyze. So in this case, I'm just going to type it out because why not? So you would want to normalize the training data and the test data. So that would be yeah, so yeah, you would want to normalize test and xtrain. Ytrain is yeah, you're right. So 2_categorical. You don't need to really, this is just converting it to encoding, and then ytrain 2_categorical y_train num_class equals 10. So then you run this one and it should say using TensorFlow backend. So now we can start splitting our data. So, and then after this, we'll make the neural network. So you want to start by splitting training and validation data, which is essentially like validating your model and training it. So from sklearn, are you guys catching up with me, or should I slow down? Is everyone like at where I am? Because it's better to tell me so I can... Okay, x_train, comma x_val, comma val. So that, and then you use train_test_split to split the training data, the xtrain, the ytrain that you recently defined, the test, and then you want your test size to be 0.1, and then you want the random state to equal 2. There's not much in like going into this in detail, so it's not going to. And then you want to print quote x. Tell me if you guys, like, if someone is getting stuck or like needs help, I can slow down or help them out. So okay, and then you copy this like 4 times, and then you change this to test. Oh wait, x_test, what I would call it. Make that x_val. Don't write x_test. And you write this is y, or ytrain. This is ytrain. This is yval. Okay, so let me just explain this block of code. Essentially, you have testing and training data for both your y and your x, and you use that here, and you define that here. So it'll split the images into testing data for you to use for testing, and then training data. So then you run this, should get something like this. This shows you how many images are being split. So you have this many training images and this many training images, as well as this many test images and this many test images. So you'll train it on these images and then you'll compare it to these ones. So yeah, then it gives you examples. So let's talk about the neural network now. So essentially what will happen, so like I'm going to go through the concept of the neural network, like how this one's going to work specifically. So you have a feature detector that's like the convolution, that's 3x3, and it doesn't really need to be 3x3, but it's like preferable, and it could be like 5x5 or 7x7. And then the feature detector essentially detects like features on the number that are essentially like convex shapes. So then what happens is it convolutes these features, and then it like allows them to look at them as important features, and then it uses like this activation thing called ReLU, but we'll go more into that. Then you have your padding, so you'll check the corners. So essentially to keep as like we keep applying convolution layers, which are the like inner layers that we talked about at the beginning, like the size of the volume will decrease fast. And so like in the early layers of our neural network, we want to like essentially make it, like extract the like edges that don't have values and just like make the number harder to analyze. And then we do the pooling. So look at that like max like features of each thing, and then we flatten all of the features that like are in the pooling output into one array using the flattening thing, and then we connect that using the density layer. So we'll tell you how that works later. So let's start by making our network. So just one cell so we start out by implementing things. So from sklearn.metrics, import fusion matrix. I'll tell you what all these things mean. Import, I'm pretty sure iter tools. From import cat2 underscore categorical, and then from keras models, import sequential. So the reason we're going to be importing sequential is because the model is a sequence of convolutions. So you want to use a sequential like operator so that like you can organize your model better. So then from keras.layers, you import dense, dropout, flatten, conv 2D, max pool 2D, and then from keras.optimizers, which is just the optimizer that we're going to use, but you'll see that in the code, import RMS prop, which allows a learning rate and is in the optimizer, and then atom. Oh shoot. Okay, and then from keras.preprocessing, I'm gonna slow down after I write out all the imports because I don't want to bore you guys. Import image data generator, and then I'm going to walk through. So the image data generator is going to essentially make it easier for us to analyze the images and like put them, in perspective. So from keras.callbacks, import reduce on plateau. Okay, so copy that down and then just tell me when you're done. Tell me, oh, sorry, my bad. Yeah, just say done or whatever. If you have any questions, ask me. I'll walk through it after. Are all of these just formatting the data representation? No, so now we're like moving away from normalizing the data. That was the top part. And we're starting to build our network. So we just have to import certain classes so that we can implement our network. Are you guys all good? Or just a few more seconds? Is everyone good? So I can move on. Okay. So the next thing we want to do is so yeah. The next thing we want to do is run the yeah, so we don't have that much left. So the next thing we want to do is make the model. So the first thing we want to do is define the model as sequential. The reason we want to do this is because we can organize it better. So you're gonna see a lot of layers here. So the first thing you want to do is model dot add. You want to add your first convolution neural network. So filters are 8. So those little like scanning things we talked about at the beginning, that's what the filter is. The next thing you want to do is add a kernel size. So your kernels are how big are your filters. So in this case, it's a 5 by 5. Like how big is the filters that scan the image. So it's going to scan 5 by 5 pixels at the same time. Padding equals quote same. Essentially the earlier concept that I explained. So like the volume is essentially going to get bigger and bigger, and it's going to get like smaller and smaller and smaller. And then so we want to make sure that like we have as much like information as possible, even when it gets smaller. And then you don't really need to worry about like the activation thing, because that's like complicated math and stuff that I kind of don't understand. So yeah. And then the next thing you want to do is input shape, because as we said, right, when we rescale the data, that the input shape would be a 28 by 28 by 1 like image, so one-dimensional. Okay, so the next thing we want to do is add another layer. Yeah, okay, so we want to add another layer. Tell me if you guys are stuck, but max pooling 2D, and then you want to make the pool size equal to 2 by 2. Does that make sense? Is everyone caught up? So this max pooling layer, the 2x2 thing, it like looks at 2x2 pixels and it sees the max like thing, and then it takes that feature out. So it takes that feature as an output. It looks at the ones at the convolution, like the output of the convolution. Is everyone good? Are you guys all caught up? Because I know it's a lot of typing. Like, are you guys understanding this stuff? Kind of cool to understand. Hello? In the chat. Okay, so are you guys caught up? Can I keep going? Any like explaining or anything? Any questions? Okay, so I'm gonna keep going then. So model.add, and you add a dropout layer, which I think I'm just not gonna explain right now because it's like a good amount of explaining to do, but yeah. Then you add, so that's your first convolution. So remember, this convolution, there's multiple convolutions in a network. So your first convolution. Okay, then your second convolution. You want to do model, I don't know why my computer keeps saying this, model.add. Your second convolution is going to be conv2d, but instead, since we decided that the volume is going to get smaller, right, each time, oh, I see why. Oh, hold on, give me a sec, I missed a parentheses somewhere. That's there. So, okay, yeah, back. Filters equals 16. So you always like, so now there's more filters, right? Then the kernel size, or the size of the filters that are being used in the convolution, is a 3x3 instead of a 5x5 this time. The padding is the same. It's the same. I already explained why that's like useful. And then the activation method, it can be relu. Okay. Is everyone caught up? Okay, so that's the start of the second convolution. And then you always want to add a max pooling layer so that you can make sure that you're getting the most important features. So in this case, I usually like to do pool size 2, and then strides equals 2x2. That makes sense. And then model dot, you want to add another layer. So now you're done with your convolution layers. Now we go to the fully connected layers that we were talking about in my brief article that I showed at the beginning. So model dot add. So you want to flatten it into one vector, as we talked about in the beginning, and then you want to dense it. Like you want to add a dense layer, because 256, so 256 is just like the amount of neurons that you want to do in the hidden layer or the dense layer that we talked about. Your activation will be relu again. And then your next one, you don't worry about the dropout, but you should probably still add it. 0.5. Like a good amount of explaining to do. And then add, and then you want another dense layer, and you want 10 neurons. Reason being, there's this is going to be your final output, right? And so you want 10 possible outputs, because like there's you're trying to calculate 0 through 9, right? So you want 10 outputs because that's 10 numbers, correct? So you want to display one of the 10 numbers. So you want a neuron for each of the options. Is everyone caught up to me? Because when we run this model, it'll look really cool. And I'll show you how to do model.summary. It's kind of cool. We're almost done. So, is everyone caught up? Hello? Can I get it? Yes. Jalen, Amy, all 8 of you guys. Or there was one. Amy, Ben, Ellen, Jalen, Tria, Sarah. Everyone caught it? Oh, sorry. Okay. Yeah, don't worry. I'll send out this to like everyone to make sure that you guys, understand it and like write some more detailed explanations. So, but still, I'd recommend coding it because it's cool. Okay, so now you want to run it. This won't show you anything, but you definitely just made a model. Oh, it's metrics. Sorry, my bad. Type it. Forgot to max pool. Sorry. Oh wait, I did. It is max pool. Everyone, yeah, delete max pooling. Sorry, my bad. I've done like 3 talks today, so I'm kind of tired. But yeah, there you go. Should run. Yeah, so it just ran. So just a side note, if you want to look at your model, model.summary is super useful. So essentially, this is what's going on in your model. This is how the outputs are working. Andrew will talk tomorrow. So, or wait, will he? I don't know. I don't actually think so. So yeah, this is how like the model, work, and like, yeah, essentially at the end though is super important because you get 10 outputs. So there's 10 neurons that essentially scan each image. Like that essentially like look through each probability of like, it being a 0, a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9. Then what you want to do is define the optimizer, or which is the atom optimizer. So you, in this case, we'll be defining it, but most of the times, like I know people who don't, which is totally fine. It just depends on the scenario. So the LR is a learning rate. Then this stuff, like, yeah. So then, yeah, the LR is a learning rate, and yeah, so then you run this. Don't get anything fancy, but at the end you'll see stuff. So now you want to compile your model. So now that your model has been built, you want to run the model.compile optimizer, because you need to optimize it. You use the optimizer that you created above. Loss. So this is a certain loss function, which has like complicated math that you could look into, but it's called categorical cross entropy. The reason you use categorical cross entropy and not binary cross entropy is because binary is when there's 2 outcomes, but there's 10 in this case, so you use more. So then your metrics, you want an accuracy metric in which you can measure the accuracy of your model. If you run that, then there's nothing too fancy, but it all comes down to this. So so what I'm writing right now, so an epoch is essentially how many times you want your model to run on it, thing. So for better results, like how many times you want your model to train on, like images and stuff. And then, so yeah, like that makes your model better the more epochs that you have. So then what you want to do is you want to fit the model. So history, so first you want to do what you call data augmentation. So you start with, that's what the image generator was for. So data gen, image data generator. I'm just going to send you guys the copy because I don't really want to type it out. So I have the copy here. I'll just send it to you. You guys can just copy this and paste it in a new cell if you want. So there's not really much to understand here. It's just like, you know, how to augment stuff. Like it explains everything, like what the process is here. But yeah, they add a different augmentation. It just makes the data easier to read and like avoids overfitting. So it essentially like centers each image at the same level. Then you just run that and actually, never mind. You don't need to copy it. So yeah, just like data augmentation is something that you should definitely look into, but like we won't put it in our model. So then you do history equals model dot fit. Now you want to fit the generator, or you do model dot fit, and then you want to train it. So fit, then you do like, so you fit it to, yeah, so okay, sorry, let me redo this. So because you do have to have the data augmentation in this one because it's easier, and like it's a lot easier to like deal with if you have data augmentation. So I'm gonna paste that back in. Yeah, so essentially what you want to do is like after this, you want to essentially fit your data to a here, let me just do an easier one, so because this one requires data augmentation. So I will fix this, give me a second. Okay, my screen share is going to turn off for a second because of switching windows, so give me 1 second, because otherwise it'll like not work if I don't do this. Okay, sorry about this. So yeah, give me 1 second. Okay, so I'm back. Can you guys see my screen? Can you guys, is it paused or something? Oh, I think it's paused. Okay, okay, so yeah, so wrote a quick model generator, and then what you do, I have to change my things because I wrote lowercase. This should be X, so you can just copy this down. It should be Y. Essentially, I'm going to run the model now, but here's how it should be looking. Let me run it all at the same time so that it works. But yeah, here's how your model should look. I'm just gonna run it now. I'm kind of running out of time, so yeah. So if you guys are caught up, and it should be looking something like this. So what's happening right now is you can see there's a loss and there's an accuracy. So its accuracy is pretty low right now, but it'll get up as the epochs start running faster. yeah, just wait for a minute, and then I'll send you guys this code so that you guys can review it and ask me any questions if you need to, because I'm always on the Discord, so just text me if you need any questions. So this will run through 10 epochs, which is like 10, ways to 10 different like ways to analyze it, and like 10 different trainings. So yeah. So it's gonna take a second because obviously it's running through big data sets, but you can already see how the accuracy is increasing on the training data, and it's getting better. So that means the model is just learning more. But yeah. Okay. This will take a while. So I'm gonna send a link to the recording and the notebook so you guys can check it out. And yeah, I think that's good enough. But you'll see how this model actually is increasing, right? So yeah. Okay. I'm gonna end the meeting now because yeah. Okay. Bye. Thank you for coming. Yeah, no problem.